Hi everyone out there. This video is all about linked list implementation. Okay, what is linked list? A linked list is a linear data structure which consists of a data part and address part. Whereas here, A consists of data part and address part. In address part, it consists of a location address of B. In B's address part, it consists of location address of C, and like that it is linked. So it is connected, which is called as a linked list. Okay, why linked list? Why not array? Array needs continuous memory allocation, but in linked list you can use scattered memory efficiently. Insertion and deletion are quite easier in linked list, whereas in array you have to, when you delete a number, you have to move all the element indexes to front, and when you insert a number, you have to move all the indexes up one level. So no prior information about memory space is needed in linked list, whereas in array you have to insist on the memory, how much memory you need, you have to insist at beginning itself. Okay, let's then linked list consists of a data part, which is a data, you need to insist on data, and next is a pointer which is a pointer which is used to traverse, and head is a pointer which points to the starting of the list, which is the starting element or the first element of the list. Okay, let me move on to the program. Yeah, here I have created a class for linked list. I am going to create a separate class for node head. I'm creating a head pointer, and I'm going to create a class node. Let me assume this class as static. A static is a keyword which says that this class is a static one which can be used at any level of the program, and it won't change its value at any cost. Okay, it consists of two parts, that is int data and then pointer. Next, now I'm going to create a constructor. Constructor will be a same name as a class, so I'm creating a same name as a class, that is node. I'm passing data and data equal to t. Now I created the node class. Now I have to insert. Public static. I'm going to return a value, so I'm not using void. Let me name my function as insert. Linked list, comma, I'm going to pass data. Okay, as it doesn't contains void, but it means this method has to return a value. So I'm writing the return statement. The error moves on. Okay. To insert a node, you have to create a node. So I'm going to create a new node. New node equal to new. No, let me call the class. New dot next equal to null. Okay, if the list is empty, let us consider this is the first element we're going to insert. Then the list will be empty. What we are going to do if the list is empty? If list is empty, so list.head will be empty. head equal to null. Then list dot head, and it will be the first element equal to new node. Else, if the list is not empty, let us assume that it has some elements, then what it has to do? Else what it has to do? Sorry. Let me create a temporary node, because if the list is not empty, what you're going to do is, look, if the list is not empty, you're going to insert the node at the end. So what you will do is you have to go traverse to the end. So I'm creating a temporary pointer and traverse to the last element, and I connect that element by changing the address section of the last element to the new node, and address section of the new node to null. Temp equal to list dot head. Okay, let me traverse. So I'm using while loop for that. While temp is not temp dot next is not equal to null, then temp equal to temp dot next. Now the traversing will be happening if the next pointer is not equal to null. Once it founds that the other section is null, it will break the loop and insert the new node. Temp dot next equal to new node. Sorry, equal to new node. Then I'm returning the list, and the insertion part is over. Let me write a function, write a method to print that list. Public static. Let me not return any value, so I'm using it as void print list. I just pass the list parameter. And to print the list, you have to traverse from the same method, same statement we used here will be used again. We will traverse and print the list. From starting to ending, we traverse and print the list. Node temp equal to list dot head. Why am I using it? Okay, sorry. While temp is not equal to null, we traverse again the same code. Let me copy it. If it is equal to null, it should okay, if it's not equal to null, it should print. So system dot out dot Print ln temp dot data. Yes, that's it. If you call this function, the list will be displayed. Okay, how to delete a number? Let me write a function to delete a number. Delete the element. If you give an element that if I have a 4, 5, 6, if you give element 5, it has to delete a number 5. If I give anything else, any number which is not present in the list, I have to print as some element not found. Let me write a function. In Java, we actually call it as method. I'm going to return the element which I have deleted, so I'm going to declare it as a returning statement, so I'm not using a void. So I'm going to return okay. Now I'm going to create a temporary node. Temp. A main issue in deleting a number is you have to keep track of the previous element too. Let me show you. You have to have two pointers, that is a temporary pointer and a previous pointer. You have to move the temporary pointer and previous pointer simultaneously. While the previous pointer will be is at C, the temporary pointer will be at C. Previous will be in B and temporary pointer will be in C. The temporary pointer will be the element which we are going to delete. So the previous pointer's next address element will be pointing to D. This is the concept here. Okay, node equal to list dot head, comma, let me introduce a new pointer, previous equal to null. If the element is found in the first element itself, if you want to delete a number 4, I have a list 4, 5, 6. If I found the element 4 in the first place itself, then I don't have to traverse all the elements, which makes the program very complex. So I'm giving a condition to if it finds the element at the first position, it deletes at the first position itself. So I'm writing a code to delete the element at the first position if it counts. While temp, if temp is not equal to null and temp dot data equal to key, then simple, you have to point the list dot head to the next element. That's it. List dot head equal to temp dot next. then system dot LinkedIn key plus count and delete then I'm returning the list. If the element is not in the first place, then the next function we use is, as I shown in the figure, we follow that method. While we are going to traverse, while temp is not equal to null and temp dot data is not equal to key. If the temp is not equal to null and the temp dot data is not equal to key, then only we are going to traverse. If we found the element, we could delete it. If there is no use of traversing. Now what we do is previous dot next. We'll move to temp position and temp will move to temp dot next position. And then what we do is we gonna delete the temp position, so we have to point previous dot next to temp dot next. That's it. We're going to do this if temp is not equal to null. If temp is not equal to null and temp dot data equal to is not equal to key, we traverse. If we found the element, we are breaking this rule, means the element should not be equal to null. Then only it means that we have found the element. If it is equal to null, then it shows that the element is not found. So this statement is important. Next, and I print element. System.out key plus same thing, found and deleted. Else if temp is equal to null, then it means that the element is not found. Temp equal to null, then it means that not found. Okay, this is the program. Now what I'm going to do is I'm going to write a switch case to access these methods. So I already have a switch case, let me use it. the names are different. Print list. What is the name here? Deleter. Yes, deleter. Okay, print list. What I have given here. Okay, these caps. Yeah, just copy and paste. Okay. Oops. I have to pass. Yeah. Save it and run. Here I have done two mistakes. That is, in print list I should display the temp value and then I should change the temp value, but I have printed it earlier. Yeah, now it will work. And then the next mistake is here previous.next equal to temp. Actually the temp value is previous.next. You have to assign previous as temp value, so it's previous equal to temp, it's not previous.next equal to temp. And I save this program and then run. Now I choose the option insert and then I insert 3, option 1, and again I insert, let me choose 8 again, and let me choose 9. Now I wanted to print the element, so I choose 2. So the linked list items are 3, 8 and 9. Let me delete an element 3. I delete the last element 9. So 9 found and deleted. If you want to quit, yeah, I hadn't done the function quit. If you want, you can add a switch case quit and you can terminate the program. Like case, let me write case 4 done equal to false. /n4 dot quit. Control S. Now what I do is it. So unfortunately I press something else. Yeah, I rerun the program. 1, I insert. Let me quit 4. That's it. Your program is now quit. That's all for linked list. Let us catch up at next video for W linked list. Thank you.